Hi, my name is Tom Lee, and I'm with a company called Quanser. And what we do, we produce laboratory equipment for typically universities to study control systems. Control is the science of making systems behave exactly the way you want it. So for us, a lot of them tend to be motion-based control. The thing that makes us unique is we deal with the very complex motion types. So simple programming will not be able to control it. You have to take the physics into account. So what you see here are 4 examples of different types of physical systems where we expose the essential control problem, which are typically complex mathematical problems. So an example here, we have this steel ball on this rail, and the goal is to have this machine keep that ball in one specific point and to keep it still. So you can imagine a rolling ball on a steel rail. It has a tendency to go all over the place. It has to measure its position and speed and then apply an algorithm that is rooted in mathematics to keep the ball still. That one is based on minimizing the vibration of that steel rod. It has a sensor inside that can measure the internal deflections. And again, a mathematics-based model and control algorithm will keep that thing from vibrating too much. In fact, if we turn the controller off, that stick would be waving back and forth wildly. Back here, 2 more interesting examples. This one is actually a model of a helicopter, and we use this to allow people to explore helicopter flight dynamics, which you can imagine is very complex. It's inherently an unstable system, and they can explore how you can use these mathematical techniques to stabilize this. And finally, fluid levels. If you have a fluid tank, you have to anticipate how you're going to keep that level at a certain point, especially if you have leaks and evaporation, that sort of thing. So all of these are used by typically professors or students or researchers to explore this thing called control systems. And it's actually very important for the programming world as well, because as you know, with the Internet of Things, everything is now about getting computers to manage the behavior of physical things. Well, if you have a really complex system, eventually you want your code to be tested on a real physical thing. If you're working with a helicopter, you're not going to get a real helicopter and try it out. That's just impossible. So these types of devices are really important for that first stage of what we call validation. Take your code and your mathematical ideas and show that it can work at least with a physical device of this nature initially. Then you build your confidence in your models and such, and then you can start scaling that up until you get to the real prototypes in the systems.